Hi, this is a presentation on mountain wave and how to fly in the mountains. So before you go for a flight, of course, you always get a pre-flight. Pre-flight departure information is extremely important when you're flying in mountainous areas. One thing you should calculate is density altitude. Typically, density altitude is given to you if you're taking off from an airport that has an AWOS machine. By definition, density altitude is the altitude above sea level at which a given atmospheric density occurs in a standard atmosphere. So meaning that on a hot day and one with low pressure, that would mean that you have much lower air density at your departure airport. So the way you calculate density altitude, there's a number of ways. One is on an E6B calculator. Or you can also use charts that are given by either the FAA or your pilot information manual. But regardless, if the air density is very low, it appears as if the atmosphere or the airplane is much higher in the atmosphere where you find that much lower density. So the airplane will be thinking that it's flying at a higher altitude just because of the low density. So you should calculate or figure out your density altitude before you depart and use that in all of your aircraft performance data. Of course, usually in the early morning hours, the air is nice and calm and smooth, no thermals, and it's also cool. So as a result of that, the density altitude is probably lower in the morning than it is in the afternoon. So you should try and make most of your flights in the early morning in mountainous areas. That, and also it eliminates the problem of convective turbulence. And of course, density altitude, high density altitude is a problem with aircraft, especially really small airplanes that don't have a very high service ceiling to start with. I remember when I used to live in Laramie, Wyoming, the the field elevation was 7,280 feet. But when the temperature was 86 and with low pressure, we'd have a density altitude of 11,000 feet or so. Of course, the service ceiling of the Cessna 172 that I was flying was 14,000 feet. So it was difficult a lot of times to even make pattern altitude. And we would assume, or we would use a much lower pattern altitude than 1,000 feet AGL. Also, weather changes quite frequently in mountainous areas, so it's good to get a full weather briefing. And also remember that there's not a lot of reporting stations in mountainous areas. They have improved over the years with the advent of AWOS, but for a while there were only a few reporting stations across the Mountain West. And also remember that a lot of times those stations aren't actually seeing the weather in the surrounding area, just the weather right above the station. And also it's highly recommended that you use a VFR flight plan when flying in mountainous areas. That way they can come looking for you sooner. You might want to consider packing some survival equipment in case you do have to crash land. And also consider your weight of the aircraft, your baggage, and also how many people you're bringing. You always want to have as much fuel in the airplane as possible, but you want to also at the same time have a lighter aircraft so you have better climb performance. So consider bringing that 500-pound anvil. You might want to reconsider that and leave that at home. Also, a lot of times local people have knowledge of the area, so you can talk to people at the local FBO pilots, but remember, of course, try and find someone who seems knowledgeable. A lot of times there are pilots that hang out at the airport that have their own opinions and aren't necessarily knowledgeable. When departing mountainous airports, consider your runway gradient. Is it uphill or downhill? You always want to depart downhill because that'll allow the airplane to accelerate faster. Also, some airports are one-way airstrips, meaning that there are mountains at the end and there's no way to turn around. So you land one direction and you take off the other. Of course, you use the same indicated airspeed for takeoff and climb as you had used at sea level, Remember that the airplane will be flying faster through the air and your true airspeed will be higher, but your indicated airspeed should be the same. Also, if you're flying instruments, make sure you check the instrument departure procedures for mountainous areas. They'll tell you a lot of times that you have to climb in the valley to a certain altitude back to the VOR and then hold in the VOR until you get above a certain altitude if you're going eastbound or a certain altitude if you're going westbound. So make sure you always check those. Make sure you lean the engine for takeoff, especially if you're departing an airport that has a density altitude of 5,000 feet or higher. If there's mountain wave present, then you want to avoid mountains if at all possible. Remember that there is no warning of mountain wave with a tailwind. As you approach the mountains, the first indication that you'll get is right over the mountain, you'll get the first wave, and then downwind, it'll be pretty rough. Approaching the mountains with a headwind, you'll notice that there are some areas of turbulence or some wave activity as you get closer to the mountains, and it'll increase usually in intensity. Fly upwind on the upwind side of the mountain, not on the downwind. Upwind you'll get, of course, an updraft and typically a smoother ride. Not always smoother, but at least you'll have an updraft. On the other side of the mountain, on the downwind or lee side of the mountain, you'll have downdrafts and more turbulence. And also, you want to make sure that you avoid flying in valleys when the wind is really strong. This is one to consider. Remember that the mountains heat during the day and cool at night, so you're going to get mountain and valley breezes, which also result in a convergence and divergence in the middle or in the valley itself. So remember that flying at night close to mountains results in downdrafts, but flying close to the mountain during the days usually result in updrafts. You want to avoid flying in a downdraft region or right down the valley, the middle of the valley, because that's where the strongest downdraft is. This is especially important if you have an airplane that has very marginal performance and you're right at the top of the valley. The airplane could be forced down into the valley with very weak downdrafts. And we're talking downdrafts on the order of 100 to 200 feet per minute, meaning that, you know, it's not real impressive, but you can't climb, and climbing is everything. Also, typically you want to fly higher than the ridge to avoid the low-level turbulence, unless, of course, you've got the vertically propagating waves, and we talked about how to identify those. As you approach mountains, you want to be able to turn quickly to avoid those. If you experience extreme turbulence, then it's easier to make another 45-degree angle turn than a complete 180-degree turn. As I mentioned, avoid flying down in the valleys, especially when the winds are more than 25 knots. And use caution when you're going over mountains when the wind speeds at the ridge level are 20 knots or greater. And winds will accelerate as they move over mountains, in effect because of the Bernoulli effect. You can think of it that way. In other words, the air is kind of funneled into a narrow channel, and it'll accelerate. So winds at ridge level are typically faster moving than they are upwind or downwind. Also, if you're in a wave, then that means that you have strong accelerations up and down, and the atmosphere is no longer hydrostatic. Your altimeter and also your airspeed indicator are based on the hydrostatic assumption of the atmosphere. So that means that you're going to get errors in altitude and also airspeed as a result of strong mountain wave. And also, always check pilot reports. Pilot reports are invaluable in giving you right information. Oxygen is usually a very good idea to carry in the mountains, especially, of course, if you're flying above 12.5. But it gives you another option, meaning that you can climb to higher altitudes if your aircraft allows you to do that, and fly above weather. Of course, as you descend into a mountain wave or any kind of mountain turbulence, you want to make sure that the aircraft is slowed down to below maneuvering speed. And that's especially the case as you descend below the ridge level of the mountains. And then, once again, on landing, consider your runway gradient. In other words, you want to make sure that you land uphill and not downhill. It'll slow your, it'll help you decelerate the aircraft on landing. Once again, same rules apply for landing as for takeoff. A lot of times there's one-way airstrips where they recommend that you land in one direction and take off another. Use the same airspeed, indicated airspeed, for landing as you do at lower altitudes. Your true airspeed will be higher. It'll throw all your visual cues off, but you should use your same indicated airspeed. That's how you fly in the mountains. I hope this was educational.